Leetcode 238, product of array except self. It's a medium type problem and might be one of the easier mediums out there, so nothing fancy. You don't need any special techniques like greedy strategy or dynamic programming or graph theory, nothing like this. Just your very basic or very fundamental understanding of arrays should suffice. And here is the description. Given an integer array called nums, so that's our only input, we have that list of ints, as we say in Python, and using that array, we have to return an array called answer, and of course we can call it however we want, but just that the output is also a list of integers and the input is list of integers. Yeah, and the output will have as many elements as the input, such that answer on position I, and that's the index I, is equal to the product of all elements of nums except nums on index I. So that's the output, that's the input, and basically for each element we want to multiply all the other elements and store the result, the product, in corresponding element in answer. Yeah, so answer is our output array, and for each index I, we'll store the result of multiplications of all elements from the input from nums except for that one element. And there are some easy ways, but of course they are blocked, but we'll get into it in a second. But still, the answer, like the optimal solution, shouldn't be very hard to understand. And the second thing is that the product of any prefix or suffix of nums, which already hints at the correct solution, we will calculate the multiply the prefix and the suffix, and those products are guaranteed to fit in 32-bit integer. And for certain languages, there are various types of integers, and some integers, if they are they store maximally, like they have a cap or the maximum or the largest number they can store. Yeah, and of course those which store maximally smaller number will take less memory, yeah, or will need less memory to be stored. And that's why they are using this or they're giving us this information, because it's meaningful for certain languages, but in Python we don't control the types. Those are handled by the interpreter behind the scenes. Yeah, we can have the hints, but even the hints can be broken, and those are just hints. Yeah, you can pass something else which doesn't fit into it, and we don't have any subtypes for integers. We have just integer as a single type. And the next thing is you must write an algorithm that runs in O(n) time and without using division operation. Yeah, so the first thing, like the first brute force way you can think about, is to use nested loop. Yeah, and for each element you will recompute the product from scratch for all other elements. Yeah, so you'll have to go through array once to take your element, and then inside in a nested loop second to multiply all the other elements. But this is not allowed. We have to have O1, not O1, O(n), just going once. Of course you can go once and then second time, but not in a nested way. And without the division operation. And the second easy way would be to just calculate the product once and that go through the array and divide this product of everything by the given element. Yeah, this would also be an easy solution, but it's forbidden. We cannot use it. And now take a look. Let's take a look together at examples. The first example, we have 1, 2, 3, and 4. Yeah, very easy numbers. And for the first element, we multiply all the other elements. So 2 by 3 is 6, by 4, 24. For the second element, we multiply 1 times 3 times 4, which is 12, and so on and so forth. Yeah, so that's the whole philosophy. And the second example is just very similar. We don't learn anything new from it. just that here they put 0. So if you have 0, then if you multiply anything else and there is like 0 outside, then it will just turn this whole product into 0. Yeah, so for example, from -1, you will multiply some numbers, but there is 0 between them, so the result you can already know that it's 0. Yeah, but we will not take advantage of this information. It's just some interesting fact. And now let's copy this. And let's think about a possible way we can solve it without violating our constraints. Let's make it bigger, a lot of space. And the first constraint is this one. Meaning we can't have nested loops. And the second one without using the division operation. Yeah, and that's it. But what we will do, we will go through this array 2 times. First, excluding the last element, and we'll go from left to right. And then from right to left, excluding the first element. And before we iterate through the array, we'll create the output array, which we'll initialize with ones, and we'll put here as many elements as there are in the input array. Yeah, so the length, the number of elements here and here is the same. And we will use 2 additional helper variables, which we'll also initialize with 1, left and right. Left and that's right. And now we will go first using left and multiply everything by what we have in left, and after each multiplication we will update the value stored here. Okay, so first we have, of course, 1 by 1, means that nothing changes, and we still have 1. But then we have 2 times 1, which is, sorry, should be consistent, and here put 1 and here put 2. And like this. And as we updated here, we also updated here. So here we'll put 2 and then 1, 1 and 2. And then we do 3 times 2, which is 6. And that's already the last multiplication of the blue line. And we store the result here. Then we go in the other direction, and we in the green direction. So the first element we go from right to left is 4. Yeah, and we multiply 4 times 1. Yeah, and that would be still 4. Just like this. Yeah, but when we want to store it here, we do 4 times 2. And we get 8. Okay, so here initially we were also multiplying, but since before the first run, all of them were 1, that was the same as if we were just updating them with those numbers, yeah? But here the multiplication is meaningful, so we had 4. And now we have 3 times 4, which is 12. And this will store here. And the last element from the green line is 2. And the previous value is 12. Yeah, so we do 12 times 2 is 14. And not 14, 24. And 24 times 1 is 24. And that's it. And as you can see, the result matches what we expected. So now let's try to do it here. We'll create the answer with 1 times the length, or maybe we can store it in a separate variable, n, length of nums. And now we create left and right, yeah, and we return answer at the end. So now we go for I in range n minus 1. And we do left times nums on position I. And the answer is updated on position I plus 1 equals left. Yes, and then for the right, we go in the other direction. So we start in range n minus 1. And minus 1, minus 1. No, sorry, we go, here is the last one is, I think, step, and here we go to 0, since we want to exclude the first element. And right equals terms of I, and then the answer on position I plus 1 also equals the result of multiplication between the current value of right and the previous of answer. And now not I plus 1, but I minus 1. Yeah, because we go in the other direction. Okay, let's try it and see if that's correct. Unmatched bracket. And for the first 2 cases, it's correct. So now let's see on all the cases. And we beat 69%